But you can still have the problem that you can get exponential running time. And here's just a little silly example. Suppose this was our graph, and obviously what you're supposed to do is you're supposed to put a million flow this way and a million flow this way, and then we're at capacity, right? But what happens is instead you're really stupid and you decide to put a flow of 1 there, right? Now you only increase the flow by 1. And then you decide to push a flow of 1 here. You push a flow 1 here and undo this flow of 1 in a flow of here, right? So you keep going back and forth between increasing the flow by 1 by adding a flow of 1 through that edge versus increasing the flow by 1 by decreasing the flow through that edge. And you keep going back and forth, and your flow increases 1 each time, so it takes you 1,000,000 iterations, which is exponential in the number of bits here, right? But the good news is that we can fix that in 2 ways. The one algorithm is if in each step you take the largest possible step of the steps which increase it, sort of maximum descent, then we can prove that the algorithm's polynomial in the number of nodes in the graph and the number of bits to write down the capacities, right? So that algorithm's really very fast. And my father proves, because they didn't care about, they still didn't like it depending on the capacities at all. They were mathematicians, not computer scientists. And so he came up with an algorithm which is polytime just in the number of nodes. But in practice, it's not as fast. And that's that. We're not going to do this. This is all about taking largest step. We're not going to do that.